In this video, we are going to talk about how to configure a CAERO3 entry for MSC Nastran. Now, we are going to be using a web application for today's tutorial. If you go to theengineeringlab.com, if you look at the top right hand side, there's a blue button. You click that link, fill out the form, you'll get access to today's tutorial. Now, this tutorial is actually available from the MSC Nastran Area Elastic Analysis Users Guide. Let's go ahead and open that up. And let me show you exactly which section it is. So this is going to be the section low supersonic filter analysis of the 15-degree swept-back wing using the so on and so on. So the goal in this video is not to fully describe this example. That would take maybe 1 or 2 hours. Here the goal is just to talk about one thing, the CAERO3 entry. How do you create it and how do you modify it? Okay, so once you get access to the free trial, you would come to the home page and you would click on the viewer. Here you would take that Nastran model and you would upload it to the web app. And now let's go ahead and do a few things. Let me hide the boundary conditions. So if I click on LBC's display panel, I can click on hide all to hide everything. And now let's go ahead and talk about what are we looking at right now in the model. So let me look at this from the top. And right now we're looking at the C quad 4 elements. So that would be this P shell row, if you will. If we want to look at the boxes, we can mark this checkbox. So let's do this. Let's go hide everything. Let's look at the panel. So this is the CAERO3 panel, and these would be the boxes. Now the boxes will change depending on the mock number you use. I think by default the preview is for a mock number of 1.5. But again, the mock number will change during your analysis. But here we only generate one preview, and the preview is for mock number 1.5. So here we're looking at the boxes. If you want to, you can also display the aerodynamic grid points like you see here on the screen. Okay, let's go ahead and now do this. How do you create a CAERO3 entry? So the way you do that is here on the bottom left, you click on pre, and you do two things. Number one, you create a PAERO3. Click create entry, and now here's your PAERO3. You fill out the inputs. And then you look for CAERO3. Click create entry. Here you say point to that PAERO3 entry we created a moment ago, and then you configure the inputs. Now, I'm not going to fill out each input because that would just take me 2 hours of discussion. And this is what I'm going to do in this video. I'm just going to walk you through existing input values. I'm going to discuss what end box, end control, and so on are. So one quick comment here. Anytime you make a modification here, so for example, say I modify end box. Here, let me turn on the boxes. If I modify the input, say we use 15 boxes, the update happens in the model here on the left, and the update happens to the corresponding bulk data entry. So notice right now it has 15. If I type in 11, now I have 11 here. Okay, so let's go ahead and I'll talk about what each of these values are. So just in case the descriptions that you see here are not enough, you can go to the MSC Nastran Quick Reference Guide. You can go to the PAERO3 entry. And one thing I do on a daily basis, I read the remarks. I go through here and I read, okay, what does this entry do? What do the inputs do? What are the limitations and so on of that entry? So again, if the descriptions here are not enough, that's okay. You can go to the Quick Reference Guide and read more about what these inputs do. So here, end box, like the description says, this determines the number of boxes in the flow direction. So I believe if you count Here the flow direction is in the positive x-axis direction. So if you count 1, 2, 3, 4, 5, 6, 7, 8, we have 8 boxes here. But the one thing to keep in mind is that the number of boxes is actually determined by these different expressions. So you take that n box value and you plug it in here, and you get the number of boxes along the span-wise direction. And then you take that value, NSB, and you plug it into this expression, and then you get the number of boxes along the chord-wise direction. So here, even though you specified 11, you do these calculations, NSB and nbox, and then here we use a Mach number of 1.5 just for this preview. And then you get a different number of boxes along the span, and then the chord direction. Okay, now what does N control do? N control controls the number of control surfaces. So let's go ahead and turn on our control surfaces for this example. So in blue and orange are the control surfaces. If I want 2, I select 2. If I just want 1, you go ahead and get 1 control surface. And if I don't want any at all, I just leave it as blank. So here, let's go ahead and go back to 2. What does X5 and X6 do? X5 and X6, let's go ahead and look here. I think I have to go to the the CAERO3 entry. In the CAERO3 entry, you get this diagram. It tells you, okay, point 1 is here, point 2 is here on the bottom left, 3, 4, 5, and 6. You'll notice that point 4 is here along the span, if you will. Right now, it's blank. The X and Y coordinates for the 0.5 are blank. What I can do, I can specify manually where 0.45 is. So let's go ahead and type in a value here and here. And let's go ahead and adjust it a little. Let's make this 0. So now you can see 0.5 is here. So let me zoom in. This would be your 0.5. So here, if you look at this, 0.1 would be at the top left, 0.2 would be at the bottom left, 0.3 would be at the bottom right, 0.4 would be at the top right, 0.5, and then 0.6 is here. Here, what I can do is I can leave that undefined. So let's go ahead and remove 0.5. So 0.5 is undefined in this example. Let's go ahead and modify 0.6. So 0.5 and 6 are optional, but here in this case I supplied it. Let's go ahead and move this 0.6 to 3.7. So I moved it to position X equals 3.7. So that's what that looks like. Let's go back to 2. And then 0.7, 8, 9, 10, 11, and 12. These are going to control the points of your control surfaces. So let's go ahead and modify one of these points. Again, I don't want to modify each point. I just want to modify a few points just so you get the idea of what's going on here. Maybe I'll go ahead and modify 0.7. So this is what the change to 0.7 looks like. Now, one thing I forgot to mention, I think it's coming up in a moment. Okay, I'll hold off on this point for now. Okay, so that's what points 5, 6, 7 through 12 do. They control points on the panel and the control surfaces. Again, whatever change we make here in the inputs, the Nastran CAERO3 entries updated for you, and the final bulk data entry is also updated here, and the PAERO3 entry that you have defined here on the right. Okay, now let's jump to the CAERO3 entry. What do these inputs do? The list W entry, this is going to specify a list of aerodynamic grid points for the panel. So here, if you go to model display panel, you can mark these checkboxes, and this is going to show you the aerodynamic grid points for the panel. So if you look at list W here on the right, it's actually pointing to an AE fact entry, AE fact 11. So let's go and find that entry. AE fact 11 is here, this first row, AE fact 11. And now this is a list of XY values. So what's going on here is you have X1, XY, XY, XY. Oh, I forgot to type today. X and Y, then X, then Y. So the first two values are going to be for 0.1, 0.2, 0.3, 0.4, and so on and so on. So that's what the AE fact entry is doing in this case. It's a set of values. So if we look at the values here, it seems like the first aerodynamic grip point is this one. Aerodynamic grip point 101. If I want to, I can make a small adjustment. Let's go ahead and make that 1.21. And we'll see where that aerodynamic grip point is. Okay, so that grip point has moved. It's now here. 101 is here, whereas before it was here. Let's go ahead and undo that. And then you'll notice that it's relocated here. So again, these are positions for the aerodynamic grip points for the panel. The next column in the CAERO2 or CAERO3 entry rather, that's going to be column list C1. And here it's pointing to AE fact 12. Also list C2, that's pointing to AE fact 13. Like before, these are the positions of aerodynamic grip points, but for the control surfaces. So let's go ahead and turn off the aerodynamic grip points for the panel, and let's turn on the aerodynamic grip points for the control surfaces. So if you look, here we have aerodynamic grip point 121 and aerodynamic grip point 122. So if I want to modify aerodynamic grip point 121 for the first control surface, I come here and maybe let's go ahead and make that 1 as an example, just to show you that 121 will actually move. Here you realize, oh no, my aerodynamic grip point is not on the control surface, so let's go back to 2.5. So again, these AE facts are controlling the positions of the aerodynamic grip points for the control surfaces. Okay, let's go back to CAERO3. Let's see, what else do we have to configure here? I believe there are, right, okay. So one thing we need to also look at are points 1 and 4. So far, I've discussed how to modify point 5, point 6, 7, 8, 9, 10, 11, and 12. How do you modify point 1, point 2, 3, and 4? So first you define point 1, and then you define point 4. Then you define the length of this edge and the length of the second edge. In these columns, x1, y1, z1, these are the xyz coordinate of point 1. So here point 1 would be in this top left hand corner. Let's go ahead and make that maybe -1 as an example. You'll see in a moment that this point moves, and when that moves, all the other geometry also moves. Maybe that's not what you wanted, so it's going to revert that back to 0. And you can do the similar thing for the Y and the Z position, but I'll skip that for now. Also, you want to control the length of this edge. So right now, the length of this edge is 2.07055. Let's go ahead and make that 3. And you see that this edge is now longer. So this is, again, 0.1, and now this is 0.2. And then 0.3 is here on the bottom right, and 0.4 is here. Let's go ahead and change the length back to its original value, 2.07. And here, let's go ahead and modify very quickly 0.4. So we'll make the x-coordinate 0 for 0.4. You notice that this point now moves. Let's revert that. Let's go ahead and adjust the length of that second edge. Let's maybe make that 3. And now you can see 0.3 is here. So we start at 0.4, and then we go a distance of 3, and then this is where 0.3 is. Okay then, so let's go and revert that value. Okay, a few additional things. Oh, I forgot the value that it was before. It was 2.075. Okay, let's go back to the model display panel. Let's go ahead and talk a little bit more. So this is how the CAERO3 entry looks like. We have a panel, our control surfaces. We also have our aerodynamic grip points. The boxes will depend on the Mach number during the analysis. So at the beginning, we really don't have a preview of what the boxes look like. Here, just for the sake of a preview, we assume a Mach number of 1.5, and it's for that Mach number 1.5 that we use to generate this preview of the boxes. So just keep that in mind. The boxes are not these constant boxes for the analysis. No, the boxes change depending on the Mach number used during the analysis. Just keep that in mind. Okay, so I think we're at the end of the tutorial for CAERO3. Just in case you do have questions, I'll leave up my contact information here. You're more than welcome to contact me, and I'll get back to you as soon as possible. And that's it for today. Thank you for watching.